everyone. So today we'll be discussing tutorial 1, KIL2010, question 9. This is related to enzymes, okay? Alright, so this one is the inhibition part of the question. So you might need to refer to your graph paper, to your references and to your, resources, okay? So you guys can check in your spectrum. So question 9 is talking about an inhibition that has the concentration of 1 gram per liter, and we are also given that this is a km, which is 9.2 gram substrate per liter. So given V and S in this form, like there are values that we need to find. I mean, we already given the values of V and S, but in what way that we need to express in order to find whether it's competitive or non-competitive. So later we'll be using the double reciprocal plot. Alright, so this double reciprocal plot allows you to draw a against 1 over V against 1 over S, okay? So this is something that you've commonly seen in the in the notes, where Km over Vm, this is concentration, plus with 1 over Vm. Alright, so this is actually a default equation. In this question, what it mentions is that there are inhibitors being used. So which means that we need to draw 1 over V equals to K prime M apparent. Apparent is the Km apparent is after we have taken the the inhibitor as part of the equation. So even if you got the results 1 over V against 1 over S, we will consider this K prime M apparent. For the constants, this is V and the denominator here is V max or Vm, is the same thing. Power multiply with the concentration of this plus with 1 over Vm. Alright, so later we need to sketch a graph. I'll just show you the outcome. It's easy. So it should be like this. So sorry, it's a bit messy. So V against S, so we need to convert this to into this 1 over S against 1 over V. So you'll get a straight line plot like this, in which the gradient is equivalent to Km apparent over with the V max, okay? Let's go back to the question. So based on the gradient that have been found, Km apparent over V max is 9.443, okay? Alright, so how do we actually find the V max? So the V max here is based on this one, okay? The constancy lah in this case. So alright, so 1 over V max is equals to around 0.601. If you guys seen in this Excel sheet, it is this one. You guys can see this is 0.601 lah for the y-intercept, okay, or Z. So V max is, let's take a calculator. Oops. 1 over 0.601, you get this value 1.664, okay. For I think this is per second lah, kan? This is per, should be per second. So and afterwards, what we need to find here is the Km apparent. Km apparent is given in such a way that we can just multiply it directly. 1.664. All right. You'll get this value, 15.713 gram S over L. Okay, afterwards, what do we need to compare here is the Km apparent and the Km found in this question. Okay, so we can see that this value is larger. Gram S per liter is greater than 9.2 gram S per liter. So what we can conclude that this is a competitive inhibition. Okay. Alright. Now let's move on to the next question where we need to find the K for inhibition. So we can use this formula straight away, where it's equals to Km prime 1 plus I over K1. Okay. So what do we need to the values that we need to use is K prime M is, let's go back here, K prime M is actually in the question, 9.2. Okay, 9.2 bracket with 1 plus the concentration of I given in the question again, it's 1 gram per liter. Ki is something that we do not know for sure, and K prime M is from the previous question, which is 15.713. Okay, 15.713. Do one by one. 15.713 over 9.2. Sorry, it's a little bit messy. It equals to 1 plus 1 over Ki. And then you can just put like 1 over Ki. You need to know how to manipulate properly. Alright. Then Ki is just 1 over 15.713 over 9.2 minus 1. Okay, let's just use calculator. 0.713 over 9.2 minus 1 divided by this one. Gives you around 1.412. The unit is, sorry, let me write over here, it's a bit not tidy enough. 1.412 gram inhibitor per liter. Alright, so this is the answer. I hope this is helpful. If you guys have any questions, please do ask. Thank you.